Here's a quick problem involving this acceleration graph right there. We've got an acceleration here in meters per second squared and a time in seconds over here. And we see that for the first 10 seconds, an object is accelerating at 2 meters per second squared. It stops accelerating for 5 seconds, and for the last 5 seconds, it's accelerating at negative 3 meters per second squared. I can ask you, what is the change in velocity over any kind of time period here? First, let's look at the change in velocity from 0 seconds to 10 seconds. Now there's a mathematical way of figuring this out and a graphical way of figuring this out. Remember, we're taking acceleration and converting it to changes in velocity. Well, what is an acceleration to a velocity? If you take the integral of the acceleration, then you find a change in velocity. If you take the derivative of the velocity, that's the change in the velocity, that'll give you the acceleration. So we're looking at an integral here. To do this graphically, what is an integral? It's the area under a curve. Okay, well I'm going to do something weird, and I'm going to look at this little space there. That space there has a height of 1 meters per second squared and a width of 5 seconds. So 1 meters per second squared times 5 seconds. That gets rid of one of those, and we get 5 meters per second. So one of these blocks is 5 meters per second. How many blocks do you have in the first 10 seconds? 1, 2, 3, 4. You have 4 blocks. Each block is 5 meters per second. It has an area of 5 meters per second. So the area under the curve from 0 to 10 is going to be 4 of these times they're each 5, 20 meters per second. You can confirm that mathematically by saying the final velocity is equal to the initial velocity plus the acceleration times the time. Initial velocity, well, we don't actually know what that is, but we're just looking for the delta, the change in velocity. So we'll just say that's 0 plus 2 times 10. Oh, well, that's 20 as well. 2 times 10 is 20. So got it. Okay. What about the next 5 seconds from 10 to 15? What's the area under the curve from 10 to 15? It's nothing. So no change. You've got no acceleration, so your A there would be 0. And it doesn't matter how much time, you get 0 meters per second. Okay, next block of time, 15 to 20. We've got 3 blocks there, but they're negative 3 blocks. So negative 3 times 5 is negative 15. The change in velocity from 15 seconds to 20 seconds is negative 15 meters per second. Putting it all together, we find from 0 to 20 seconds, we get positive 20 in this, negative 15 in that, and we find a total change in velocity of 5 meters per second. From this point in time to that point in time, we changed our velocity by 5 meters per second. Well, if our initial velocity was actually 12 meters per second, let's just say, we never really talked about what the initial velocity would be. All the way up here I said, let's just say it's 0. What if that's a lie? What if it's not 0? What if the initial velocity was actually 12 meters per second? Well, if our change in velocity is 5 meters per second from that point to that point, then our final velocity must be 12, our initial, plus our change, 5, which is 17 meters per second.